So the whole goal of this one is to convert it from rational exponents to a smaller fraction, essentially. So what is the greatest common factor of 10 and 12? That would be 2. So that's going to give me 5 over 6, right? Okay, so now we're going to look at our exponents. And we know that if we have the same term in the top and the bottom, we can subtract. I should write this better. If we have the same terms in the top and the bottom, we can subtract their exponents. So we can say x equal x to the a minus b as our exponent rule. So a to the 4th over a to the 8th is going to give me a to the 4th in the bottom. Okay, so really when you do this, you get 4 minus 8. That's going to give me negative 4. Well, we know that negative exponent means flip it onto the bottom. Okay, b to the 7th over b to the 5th. That's going to give me b to the 2nd, because if I subtract those exponents, I'm going to get b to the 2nd. And it's going to stay in the top because it's already positive. Okay. On the next one, we're going to look at our numbers. So for 18 and 24, what do they both have in common? 6. So I'm going to divide 6 in the top, which is going to give me 3. And I'm going to divide 6 in the bottom, which is going to give me 4. Okay. One thing that I would suggest doing before we get started on these variables is if you have a negative exponent like this, negative 3, I would go ahead and flip it to the bottom, rewrite it, and then try to simplify. So for instance, this is going to look like a to the 2nd, a to the 3rd, and then everything else is going to remain the same. All right, so now we're going to simplify. So this is going to be 3 over 4. We're going to add these exponents because of the product rule. So this is going to be a to the 5th. Then b to the 2nd over b to the 5th is going to give me b to the 3rd in the bottom. Okay, remember, if it's going to be negative in the top, we're going to flip it to the bottom to make it positive. And we're going to subtract our c terms. So 6 minus 4 is going to give me c to the 2nd power. So now what we're going to do for number 3 is we're going to multiply those exponents. Yeah. So 3 times 2 is going to give us 6. So it's going to be p to the 6th over 4 times 5 is going to give us 20, right? Okay, so then we're going to simplify this exponent because ain't nobody like big fractions. So 6 divided by 2 gives us 3. And 20 divided by 2 is going to give us 10. The reason why I'm dividing by 2 is because that's the greatest common factor of 6 and 20. Okay. It does tell me to write it in radical form. So with that being said, remember your denominator is going to be the root and your numerator is going to be the exponent. And what I mean by that is when you write this in radical form, you're going to do radical. P is going to go underneath the radical. 10 is going to go out here in this little like cubby hole. And then you're going to have 3 as an exponent. You're not? All right, so now what you're going to do is you're going to multiply 2 times 1/6 and 2 times negative 2/3. So we're going to go ahead and do that. And that's going to give me, and I'm sorry that this is written weird. Okay, so w to the 2/6 power over w to the negative 4/3 power. That looks gross. I don't like it. It's not fun. Okay, so we're gonna simplify this exponent just to make our lives easier. So we know that 2 to the 6 or 2 over 6 is gonna be 1/3, right? So this is gonna be w to the 1/3. And you know there's like negative right here. Well, let's go ahead and flip it to the top because again, ain't nobody like negative numbers, right? So that's going to be times w to the 4/3. Now this has become very, very nice. We're going to add our exponents together. So 1/3 plus 4/3 is going to give me w to the 5/3. Oh yeah. Okay. And remember, our exponent, the bottom, the denominator is going to be our root, and the top is going to be our exponent. So when we write this out in radical form, we're going to have w underneath the radical with 3 in the little cubbyhole and 5 as the exponent. So if I was trying to simplify this guy, you see how there's a 3 out here and there's a 5 underneath the radical? Okay, well, what I tell my kids is that, let's say this is saying that you have 5 things, right? And you want groups of 3. Okay, well, here's a group of 3. Well, how many groups do I have? 1. So this is going to have a W left out on the outside. And how many people do I have left over? 2. Those 2 people have to stay on the inside. They're not invited to the party. Okay? So this is my final answer. Yeah. Oh. Who's terrible at this? It's me. Okay. I know you're starting to freak out. And it's fine. So what we're going to do here is, the first thing we're going to notice is that there is a 3 in this little like root cubbyhole space. Okay, so that's going to really kind of drive what we're about to do. So we need to take the cubed root of 12. That means that I need to figure out factors of 12 that I can pull out to get the cubed root. I'm going to suggest something small, like, for instance, well, give me factors of 12 really quick. 2 and 6. So then when I break those down, I get 2 and 3, right? Well, there's nothing here that I can really, like, pull out to make this smaller. Okay, so with that being said, though, you see how it has 12x squared and 4x in the denominator, right? So couldn't I take, I can't. So I'm subtracting those exponents. So again, sorry, I paused this. But what we said was 12 divided by 4, that's going to give me 3. And x squared divided by x, that's going to give me 1x. So then it's just going to be root 3, or cubed root of 3x. Oh, and this is terrible. Okay? Okay, so on number 6, what we're going to do is we're taking the cubed root of 48, a to the 7th, b to the 3rd. So let's look at our numbers first. So if I take the cubed root of 48, I need something that if I multiply it by itself 3 times, I'm going to get 48. So if I multiply, or if I break this down into factors, this is just how I do it. You can do it another way. 12 and 4, and I break this down into 4 and 3. I break these down into 2 and 2, and 2 and 2. I need things that are in groups of 3. That means that it's represented 3 times. So for instance, this 2, and this 2, there's 3 times that you see 2's, right? So that means I'm going to take a 2, pull it outside, and what am I left with on the inside? So that'll give me 6 on the inside. Okay? So with our variables, what's going to happen is, this is like saying that there are 7 A's, 3, 4, 5, 6, 7 A's. I want groups of 3's, right? So I'm going to circle this group and circle this group. How many groups do I have? 2. So I'm going to say a to the 2nd power. And how many people do I have left over? Okay. Then I'm going to have 3 B's. I want to make groups of 3. How many groups do I have? So this is going to be b to the 1st power. So I'm going to rewrite this because I know you can't see it. 2a to the 2nd times b root 6a. And we got to make sure that we write that little cubed in there, because otherwise it's the square root, right? All right, so on number 5, I was just told that I was missing that the cubed part, or the cubed root. So make sure that you put that little 3 there. Yeah.